Hey there, tech fans. Rick here again with a brand new product that I think you're going to really like. It's an external drive enclosure for the very latest storage technology that's based on NVMe. Now, if you've never heard of NVMe before, it's hands down the fastest storage technology ever produced, and it's something you should pay attention to because I believe that it's the next evolution in how we store data, both internally and externally in our computers. Now, NVMe stands for Non-Volatile Memory Express, and I love this product because it's one of the very first products that actually treats NVMe differently than it treats other external storage technologies. Now, I'll get into all that in a minute, but the product is designed by our good friends over at DockCase. Now, if you've never heard of this company before, they make a lot of really cool products that you can connect externally to a laptop or a computer, things like a USB-C dock or card readers, things like that. But they're a clever company because they're always building really durable products that are smaller than most other products on the market, and they build in a lot of sort of wizard features into them that allow you to do things that you can't do with some other products on the market, and I'll kind of get into that at the end of this conversation. But I wanted to start off with just a quick unboxing to show you everything that's included with the kit. So when you pop open the box, you're going to find the actual case itself. You're going to find a screwdriver because you need to install the NVMe drive inside this unit, and you also find a connection cable. The unit operates off of a USB-C connector, so on this end you've got a USB-C. On the other end you have a full-sized USB-A if you have an older computer, or watch this, you can pop that off and it's a USB-C underneath. So whatever you want to connect this to, you've got both styles of connectors right here. Now, I've done a lot of testing with this, and why I'm so excited about it is because I do a lot of video editing. I transfer a lot of large files to my laptop, to my computer. I'm on the road a lot doing presentations for customers. I have media players at home. A lot of times I want to watch a movie on there, and those files can be gigantic. They can be 5 gig, 10 gig large. And SSD drives, which is the drive I use normally, works okay, but it's slow for transfers. A lot of times you can't stream off it because you can't move the bits fast enough out of the technology to actually watch that video. NVMe solves all that problem. NVMe is a technology that was designed by Martians, and it's been around for a while, but a lot of companies are just starting to pick it up because where it started was in the enterprise space. So I've worked for a lot of large companies in my career, and in the enterprise space, customers are always concerned about density of storage and, more importantly, speed. And NVMe is incredibly fast. It's wicked fast. Now, just to give you a little bit of a history, we've all been around a long time. So I started way back in technology when disk drives were as big as washing machines. But with PCs, we kind of all are familiar with this type of drive. This is a hard drive. It's based on a SATA protocol, SATA protocol, or SAS protocol. And the challenge with a SATA drive like this is that, number one, it's a mechanical drive. So inside there's a platter that looks like a record that spins around, and there's a little arm. It's an actuator that moves around across that platter to drop bits on the platter and retrieve bits on the platter as you're depositing data and pulling data off the drive. And it works really well, and they've gotten really fast, they've gotten really dense, and really low cost as well. So you can store a lot of data on these, but it's not really wicked fast. So if you're trying to do video editing, it can slow you down. If you've got it as a boot drive in your computer, it could take a while for the computer to wake up when you first turn it on. So good technology, but the challenge is for this to talk to the backplane, and the backplane is what connects the CPU to your disk drives. It's going through an interface card, an SATA interface card, so there's a lot of handshaking and interpolation that goes on between the backplane speeds and this, and typically that interface is what slows it down. So manufacturers decided, you know what, we got to get away from these physical actuators moving around on top of platters, because again, the problem with this is that it's a serial device in the sense that it can only deposit data at one point at any given time. So if you've got to search across the platter to drop data here and pick up data over there, it takes a long time to move across that platter. So what they did next was come out with a solid state drive. So a lot of us are using SSD drives in our computers. Hopefully you are for your boot drive. That'll speed things up tremendously. This is not a mechanical device. It's purely digital. So what you've got is a large storage area that can deposit data very quickly across that entire schema of storage capacity inside that drive. The challenge is most of the companies out there plug this into a SATA adapter. So you've still got that interface issue where it throttles the data getting to the SSD drive. Now, if you're dealing with external drives, it's even worse because it's got to get transferred through a USB cable to an external drive, and you don't know what kind of controllers in the external drive, so it can be a fairly sluggish process. Well, the next evolution is to take this solid state technology in an NVMe drive like this. Now, this looks a lot like the memory in your computer for a good reason. It connects directly in your computer to the PCIe bus. So you can plug this right in. It's talking at bus speeds. But up until now, it's been mostly an internal computer product, or it's been like an enterprise product that customers are using in large data warehouses. This company was one of the first ones that actually put together an external enclosure for it. And it's not just a simple matter of plugging this to an external controller and then plugging it into your computer through a USB-C, because NVMe, to really take advantage of this, uses a brand new type of topology. And what I mean by that is the language of how I move data back and forth between an NVMe drive and an SSD drive are completely different. Now here's the confusing thing. Both of these are SSD drives. This one is NVMe, this one isn't. And the reason that's important is because NVMe is a storage technology, but it's also a language of how I get the data onto that storage technology. And it's based on a concept called NUMA, which is a kind of a nerdy thing, but NUMA is an architecture that can scatter and gather data really efficiently across the wide range of different positions on that storage. So NUMA architecture allows the computer to talk to that storage device in multiple languages, if you will. And the simplest example I can give you is when you're in the SATA world, say you're at a party and there's 30 people in the room and you want to have conversations because a lot of your friends are in the room with you. You may walk up to a person and start talking to them, and if somebody's talking to you over here, you can't really pay attention to both of those people at the same time. So you have to talk to that person and say, excuse me a second, and then turn and talk to this person. That's sort of a serial delivery, and that's what SATA suffers from. And SSDs are a little bit better where you can actually talk to multiple people at the same time, but it's still tricky because that SATA interface slows it down. With NVMe, because it's using NUMA architecture, it's incredibly cool. It's using PCIe connections inside the computer. And what that means is now you're at that same dinner party and there are 35 people in the room. You can talk to all 35 people at the same time and keep track of those conversations simultaneously. More importantly, they can be speaking different languages. Now think about that for a second. You've gone from one person, one conversation, excuse me, and turning your head, to 30 conversations, French over here, British, English over there, maybe German over there. Who knows the languages? My point is, it's a multiple threaded, multiple queue environment, which means I have 64 queues I can open up, which are lanes to get into the actual storage. And I've got multiple bits that I can throw across those lanes simultaneously. So it's not only faster storage, but it's more brilliant in the way that we move data to that storage. And that NUMA architecture is the future of computing in a lot of ways. So it's not just used for storage. You'll see it widespread in computers coming out very soon. Some are already on the market today. But anyway, NVMe is the way to go. Now, the reason I care about it is because, again, I do a lot of large data transfers. If I'm traveling for a business meeting with a client, I've got to move a lot of large files to an external drive really quickly to get out the door and get on the airplane. This allows me to do it, and it is so fast. It's almost like I didn't trust it the first couple times I used it, because I've had this drive, I don't know, a month or so, and I've been testing it like crazy. And I'm using, by the way, a Samsung NVMe drive. So when you buy this product from DockCase, it's just the enclosure. You have to buy an external NVMe drive. So it's sort of like you're buying an enclosure for an SSD drive and then buying the drive to stick in there. And these NVMe drives are available like in 1 terabyte, 2 terabyte. I think there's a 512 out there. This is a 1 terabyte. For my money, a terabyte of storage of NVMe is big enough, easily big enough to handle all the files I need. And if I'm taking up too much space, I'll pull a couple off, but not really expensive. It's in the price range of a pretty dense SSD. But anyway, you buy the NVMe drive, it sits inside here. But the cool thing for me is that the speeds on this are absolutely incredible. So I did some benchmarking. Now, my test conditions were this. I've got an older computer that's got an internal hard drive that's on SATA. So it's plugged into a SATA bus. I came out of that computer through a USB 3 interface, right? So it's a USB-A interface. I didn't use the USB-C because I wanted the level test across all of them. So I did 4 tests just to show you the relative difference between them. The first test, I basically did a copy of a 10 gig file across the backplane. So it's disk to disk, both of those are SATAs. And that was pretty quick. The internal test was 165 megabytes a second, which is pretty fast. So I can move files internally in the computer pretty quickly. Where it got tricky was when I tried to move files externally. So the first test I did there was with a thumb drive. And that USB thumb drive only moved files at 18 megabytes a second. That's creepy slow, right? That's like, do that, go out and make a sandwich, come back, maybe you've got the file transferred. And that's what most of us are using, those USB thumb drives. Now, if you have a newer version of USB, maybe 3.2, it gets a little bit faster. You got better thumb drives, it gets a little faster, but it's still like dinosaur level as far as transfers go. All right, so then I thought, let me connect up an external SSD drive, because that's got to be super fast. That's the one I'm using today. So when I did that test, it clocked in at about 45 megabytes a second. Now again, it's going to vary if I'm moving multiple files, but this was one clean file of 10 gigs, moving it off the internal drive to an external SSD. So it's way faster than a USB drive, and up until I got this product, that was good. That was good enough. That's all I had, but it did make it hard to edit videos on that because the transfer rate was so low. So I kind of had to move everything into my internal drives and do the editing there. When I connected this guy up, that same 10 gig file, and just transferred over to the NVMe, I was moving data at 330 megabytes a second. It's super fast, and this goes even faster. It can go up to just about a gig a second. But imagine for a second having a 4 gig file that used to take a couple of minutes to transfer over to the SSD, and it's over there in a couple of seconds on this one. So it's screaming fast. But in addition to that, the folks from DockCase have built in a lot of other features inside this unit that really matter. So for example, when you're using solid state drives, they can fail on you pretty quickly. So unlike hard drives over here, this one, which has a lot of metrics going on in the background, where you'll see things like correctable errors, uncorrectable recoverables, and then eventually uncorrectable unrecoverables, it complains an awful lot before it dies. So you have a really good idea that that's gonna go, and you can back it up and get the drive out of your computer if you're watching that kind of thing. With solid state drives and NVMe drives, it's a much quicker decay. They can be working in the morning and fail by evening. So it's important you keep an eye on how these things are doing. And with SSD drives in your computer, unless you're going into the metrics and looking at things like that, you really have no idea how many times you flip bits inside of a solid state drive, even more so in NVMe because it's faster. So if you're not watching that, these can be working at breakfast and fail by dinner, and that's scary. So what DockCase did was built in metrics and sort of analytics that look at how many writes and how many rewrites and erasures have happened on the NVMe drive. It also looks at the health of the drive because there's a lifespan on these things. It's sort of like, I call it the paperclip syndrome, where you can bend a paperclip so many times that it eventually breaks. It's the same thing here. When you're flipping bits inside that drive, it only has so many flips per those bits. Now there's billions of bits in there, but still, it's gonna wear out over time. This has got a display in the front that when you first boot it up, it tells you the health of the drive. So it tells you the use of the drive is 2%, 5%, 12%. So you use it for a couple of years, and it will be a couple of years unless you're moving big files forever. It'll tell you, hey, you're at about 85% usage, 90% usage. Maybe it's time for you to move that data off that NVMe drive onto your computer, pop in a new NVMe drive and move it back in. But I love the fact that it lets me know that because it takes all the worry out of it. When I use SSD drives, I'm always wondering like, man, oh man, I wonder how much life's left in that SSD, and I have to remember to go in and check it. One other thing to do here, which I think is, again, a brilliant move, is that they've got a super capacitor built in. So when you first plug it into the USB interface, it'll charge up that super capacitor, because what happens is if you yank this when it's transferring data, or if it's doing some kind of like connection with the computer, some handshake with the backplane, and you yank it, you break that communication, you can actually corrupt the drive. And that's a really bad thing, because sometimes it's just the file you lose, sometimes it's the entire partition that's gone. So this unit has a super capacitor inside that fully charges up, and if I disconnect the USB, that capacitor will keep this thing powered up for 10 full seconds, meaning if I'm still doing data transfer, or if there's data in the cache on this unit, it hasn't moved to NVMe yet, it has enough power to move it over to NVMe, so you're not going to have any issues with that. I also like the fact that there's a button on the side where I can move deeper to the menus to actually look at exactly what's going on inside the unit. So they've thought of everything, and the case itself is just gorgeous. It's all extruded aluminum. It's got a beautiful glass top on it here. The back of it's got heat fins that are built in that have graphite composition on top of them, and if you know anything about heat dissipation, heat fins are important, but graphite is the perfect material to actually get rid of that, evacuate that heat in the drive. So NVMe is going to get a little bit warm because you're moving a lot of data to it, but having these fins on the back and the graphite coating on it just means it's going to be really cool when you're using it. So everything about this thing is just designed to be perfect. I just love this thing. And I can't tell you how many times I'm out with clients and I'm bragging about this thing. I'm saying, hey, have you guys seen this new NVMe drive here? Look at this. And everybody wants one. So this is the future of external storage. Now, what I want to get into next is I want to show you how to put the NVMe drive inside the unit. It's incredibly simple. It's 2 screws. You take one screw, the back pops off, the other screw lets you put the drive in and then screw it down, put the back on, put the screw back in, and you're good to go. There is a little pad inside here that contacts up against the NVMe, and that transfers the heat from that NVMe drive to the heat fins and eventually out to the air. And then the last thing I'll show you is some of the menus. I want to give you an idea what the menus look like and take it from there. But again, from my perspective, I'm always trying to stay ahead of new technology. I'm a nerd that loves new technology, so I'm doing research on all emerging technologies around batteries and storage devices and computers and drones and everything else. And when I saw this product come out, I've been looking at NVMe for a while for the home computer, and I'm thinking, man, sooner or later, somebody's going to come out with an external enclosure where I can slap an NVMe drive in it and move on. And DockCase beat him to the punch. And not only did they beat him to the punch, and there are probably other companies that have them, but nobody's as sophisticated as this. The other ones may just be dumb enclosures that maybe do some kind of interpretation between USB and an NVMe interface. This one has a controller inside that actually flatters that NUMA architecture on the NVMe drive. So all the things you want to do, where it's got that scatter and gather technology to the storage, happens inside this drive, on top of which they thought about what about a power failure and built in the supercapacitor to make sure there was plenty of power in there to make sure those writes eventually made it over to the NVMe so it was non-volatile. So everything you could want in a drive is here. And right now, I guess it's a Kickstarter program. I don't know, when I post this clip, it may be a live product, but I was lucky to get it early, and I love testing new technology like this. So if you stay tuned next, I'll show you how to change it, put the drive in it, and get all that set up. And then I'll come back at the end with a couple of points to keep in mind if you're in the market for an external drive. Maybe hold off on buying that SSD drive. Just hold off a little bit. Look at this one. Price this one with an NVMe drive in it or an NVMe stick in it. You're going to come pretty close, but again, the speed on this thing is it's like a rocket ship as far as moving data over to it. I still can't get past how fast this thing can move data. I just love it. It's the perfect drive. So anyway, stay tuned. I'll do the closer look, explain a little bit more about it, show you how to put the stick in it, and then I'll come back with some final points. The kit is complete and includes everything you need to get started except for the NVMe drive. When you open up the box, you'll find the external enclosure, a nice screwdriver that's got a tiny little Phillips head in the end. You can use this to actually install the NVMe stick inside the unit. You'll find a screw that'll hold the drive inside the cabinet and 2 spacers if you need those for different styles of NVMe drives. You'll also find a full instruction manual that gives you all the information you need to understand how the menus work and some of the statistics those menus will give you. It's good to read through these so you understand exactly how to use the product. And then also you'll find that cable I'd mentioned a minute ago, which is basically a USB-C on this end, which plugs into the side of the drive. And the other end is kind of clever. They've got a full-size USB-A adapter on there. So if you've got an older computer, you can plug this into any standard USB-A port, and you'll see that it's a USB 3 based on that blue. But if you have a newer computer that's got a USB-C port, you can use this. So the cable itself will plug into USB-C natively, or you can pop the adapter on to plug into older computers. So no matter what you're connecting to, you've got the right connector with you. I like that these are attached too, because that way you're never going to lose this one if you're out on the road. So that's the cable. Now, the cabinet itself, again, I can't get over the design of this. It looks like something that came out of the NASA labs. They really built this thing to be sleek and durable. It's an aluminum case. It's got heat fins on the back. Those heat fins are covered with a graphite material that actually helps that heat evacuate from the inside unit, because it does get a little warm when you're operating it. But heat fins on their own are great, but if you have a special coating on top there, that can really accelerate that heat transfer to the air around it. A single screw here that opens up the back, really simple to use. You'll also find a button right here. When this first boots up, it'll give you a lot of information about the current status of the NVMe stick that's inside there. So it'll tell you if it's good, if it's not good, and a lot of stats about how much has been used of the stick, capacity. It'll also tell you how many times it's been used, how many writes and rewrites and things like that. But also, if you want to go a little deeper, you can push that button. It'll take you to a deeper menu that gives you a lot more statistics about the health and welfare of that stick internally. So if you're really concerned about it, especially if you've been using it for a couple of years, maybe tap that button every so often to get more details on it. On the one end, you'll find the USB-C port, and that's used with the included cable. Plug this in here, plug this into your computer, and that's all you have to worry about. Now I'll show you how to actually install the NVMe stick. Now the one I'm using is a Samsung stick. It's a 1 terabyte drive. Again, you can get these, and I think in 512, 1 terabyte, and 2 terabytes. By the time I publish this, there may be a 4 terabyte out for all I know, but installing it is incredibly easy. You use the included screwdriver to take this screw out. Just a single screw is all you need. That'll pop out. Don't lose that. I always try to do this on a flat surface so it doesn't pop off and go running off into the carpet on me. But once you do that, the back pops off. And that's the only screw holding it together. Now you'll notice a pad right here. That's a thermal pad that comes in contact with the top of the NVMe drive and helps to transfer that heat from the NVMe drive to the heat fins on the back. And inside you've got a connector down the bottom, and you've got a mounting post right up here. And to install this, always do this with a grounding strap. I'm breaking my own rules here because these are fairly sensitive to static electricity. Luckily, I just grounded myself, so I'm good. Old joke in the engineering profession is that I have very low potential, which is kind of a nerd joke. All right, anyway, this pops in here on this end. You'll put it in up like this first, and then seat it, and then gently push it down like that, and then use this screw to hold it down at that point. So you'll set the screw right there, and use the screwdriver to tighten that down. Now again, you can use those spacers if you need to. With this one, I've been using it for a while, so I know I don't need the spacers, and that tends to ground the stick, which is nice. I like that. Not too tight, you don't want to crack the stick, but just tighten it enough where maybe 2 fingers tight, and then put the back on again. And again, to do that, there's a little tongue right here, fits in a groove on this end, slide that in, and then use the other screw to actually put the back on. So once you do that, Again, tighten it up here. You can go a little tighter in this one because it's metal to metal. And that's it. It's just that simple. Now, when you first boot it up, it's going to come up as an unformatted drive. When you connect it to your computer, you can format it to whatever preference you have for formatting. Once you do that, you'll see all the available capacity on the display. You can start firing files at it and use it like you would any other external drive. But again, I'm telling you, every time I'm on a trip with clients and I pull this out of my bag and start moving files across, everybody wants to know what this thing is. And I could not be more proud of it. I just love it. And I know I'm getting excited about storage, but when you move as many files as I do, move as many bits around as I do, something like this really can change the game for you. So there you go, a little logo on the back designed by DockCase. And again, I like it a lot. Good product. I hope that closer look was helpful. Now here are a few key things to keep in mind if you're searching for external storage for your computer or you need a portable storage solution for your laptop. And as I mentioned, there are basically 3 different flavors of technologies available on the market today, starting with the hard drive. They've been around forever, they've gotten really big, so you get good density out of them, and the cost has come down an awful lot over the years. So it's a great solution if you need a lot of storage, internally or externally in your computer. It's also a great solution if you just want to back up your files that are really important to you, and then take the drive and put it up on a shelf someplace. And that way, if you lose your laptop or your computer blows up, you can restore those files to your new computer. So great solution there. Not a great solution for an external drive because again, it's been eclipsed by the solid state drives because the price on these two are getting closer and closer. And I would go with the solid state drive for an external drive because it's way faster, draws less power, it's smaller, it's easier to bring with you. So solid state drives are the answer. They're also great as an internal drive. So for example, if your computer is still booting off a hard drive, you'd be shocked at how much faster it'll boot if you put a solid state drive in there and clone that drive over. So solid state drives, up until this product came out, were really the go-to product for an external drive. That all changed. When this product hit the market for me, NVMe is all I want to talk about. I mean, solid state drives are cool, but that's my dad's storage. This is my storage. This is the thing you want to look at. So if you're like me and you're moving a lot of big files, you're moving files an awful lot, you want to do video editing on an external drive, you want to stream things off an external drive, NVMe is the answer. And again, up until now, it was impossible to find an external enclosure that would hold NVMe drives that had the smarts and the protections built in to really flatter that drive. Until the DockCase product came along. Now, I expect the market's going to get flooded with a bunch of other vendors out there. But again, keep in mind what DockCase has done in their Generation 1 product has built the NVMe controller inside, which handles that NUMA architecture to flatter that data moving across to the NVMe drive. They've also built in an incredibly cool digital display up front that gives you every bit of data you need to know about the status of that NVMe drive. Because as I mentioned, these things can blink out like a light bulb, but if you watch those stats, you'll know that, hey, it's getting a little older, it's getting a little older, maybe I should get it out of there. So that's built in. And then the key feature for me is the supercapacitor, which again is a cool word, supercapacitor. But anyway, the supercapacitor acts like a battery that you never have to change because every time you plug it in, the electrons go into the capacitor, they charge it up, and when you unplug it, that capacitor provides voltage to the NVMe storage inside to make sure all the writes that hit that interface actually make it onto the NVMe drive, so you're never going to have an issue when you boot this thing up next time where you've got a corrupt drive. So those are 3 important factors if you're looking for NVMe, but my suggestion would be old school, newer school, and now the latest. And this thing is a rocket ship, and I just love this product. So anyway, that was it for today. I know I went on a little bit longer, but I can't help myself when I talk about technology. I got all wound up, especially NVMe stuff. But anyway, if you've got questions, drop those in the comments below. Again, it's a Kickstarter project that's about to launch. I think there's a couple of days left before it goes live. You can get some pretty good deals on it during that Kickstarter campaign. So check the links below, go over, check it out for yourself, see if it's right. I think it's a beautiful product. And again, as an engineer and as a person who's designed a lot of products, you know, major props for this. This is just a beautiful design all the way around and a product that I think is as good or better than most Generation 2 products will be from other companies. So that's my 2 cents on it. Anyway, thanks a lot for watching. I really hope you enjoyed this because I know it has nothing to do with drones or other technology, but I know you guys are nerds like I am, so talking about this kind of tech should excite you. Anyway, thanks again for watching, and until next time, stay nerdy.